Good evening everybody. Welcome my YouTube channel on electromagnetic theory. Today we'll discuss about the derivation of Coulomb's law from Gauss law. So as we know that from the Gauss law we know that the flux coming out is equal to the charge enclosed, and from that we can write, instead of psi we can write it is nothing but surface integral of dds is equal to q. Now as we know that this one is equal to surface integral of epsilon into E into ds, that is equal to q. Now from that we can get surface integral of E ds is equal to q by epsilon. So if we are taking the air as medium, then obviously it will be E0. Now if we will apply this one to the spherical coordinate system, then we know that the area of the sphere is nothing but 4 pi r square. So E into 4 pi r square is equal to q by epsilon. From that we can get electric field is equal to q by 4 pi epsilon into r square. Now we know that E is equal to F by Q. So putting E is equal to F by Q in this equation, suppose this one is equation 1. If we put the value of electric field, so in this equation instead of electric field if we write F by Q, then we can get the equation 1 can be converted to F by Q is equal to Q by 4 pi epsilon into r square. So this gives you F is equal to Q into Q divided by 4 pi epsilon square, which is nothing but Coulomb's law. So this one is verified. Suppose we will take this one as equation. So this is nothing but the derivation of Coulomb's law from Gauss law. So next we will discuss what do you mean by work done, and we will discuss about the absolute potential. Now next one is the work done. So what do you mean by the electrical work done? Suppose a charge Q is placed at the point P. Now the direction of the electric field will be along this direction, from positive to negative charge, and we know that the direction of electric field is nothing but the direction of the applied force. So to keep the charge in equilibrium, we have to apply a force, suppose it is Fa. Now to keep that charge in equilibrium, suppose, so now suppose dl is the distance that is being moved from A to B. So dw is equal to Fa into dl. Now we know that Fa is nothing but minus F. So from that dw is equal to Fa into Fa dot dl, because we know that the work done is nothing but a scalar quantity. So from that we can write down this one as integral of dw is nothing but w is equal to Fa into d. Now from that we can get that this one Fa, instead of Fa we can write, so it is nothing but Fa into, we know that E is equal to F by Q. So from this one we can get F is equal to E into Q. So now this is nothing but, this is line integration. So instead of F we can write E into Q. So it is E into Q dl, and it is, suppose it is moved from the distance A to B. So this gives you W is equal to, Q is a scalar quantity, so it is a constant that can be taken out, and the integral will be from A to B, and it is E dot d. So this is nothing but the expression of work done, electrical work done. Now next one we'll study about the absolute potential. So how it is defined, first we should know what is the definition. Absolute potential is defined as the work done in bringing an unit positive charge which is placed at infinity up to the point P. So what is the work done? So now against, we can add that one, that it is against the, because unit positive charge whenever we are moving from infinity to the point P, and obviously we know that it is also a positive charge. Now there will be repulsive forces. That means we are moving the unit positive charge against the electric field. So from that we know that dW is nothing but minus E into dx. Suppose it is dx, we are moving it from A to B, then we will take the integration and put the limit of x. Now dW is equal to minus E dx. Now what is that? Now E, we know that it is equal to E dot I. E dot I. And dx is nothing but minus dx into dx. So if we multiply this one, so this is exactly dW is equal to E dx. So because we are moving the unit positive charge, so it is nothing but dW, we can write this one, and we are moving from A to point B against the electric field. Now we will take that one as the limit, that will be, the limit will be from infinity to R. So integration of dW is equal to W is nothing but, now it is nothing but EI dx, it is minus dx, so minus will be coming out. So we know this dW, integration of dW is nothing but W, and from that we can put the limit is from infinity to R. Now if we will integrate this one, this work done is nothing but potential. So it is equal to, now we will put the value of E, that is nothing but Q by 4 pi epsilon into x square. So I dot I, that will be 1, so it is dx, and the limit will be from infinity to R. So that will give you V is equal to minus Q by 4 pi epsilon, and that will be taken out because it is a constant, and the limit will be from infinity to R, and it will be x to the power minus 2 dx. So the integration of this one will be minus Q by 4 pi epsilon x to the power minus 2 dx, it will be coming minus 1 by x, because if we integrate this one, it will be x to the power minus 2 plus 1 by minus 2 plus 1, that will be minus 1 by x, and it is from infinity to R. Now putting the limit, it will be minus Q by 4 pi epsilon. If we put the upper limit, that will be minus 1 by R plus 1 by infinity. In place of x, we will be putting the lower and higher limit. So 1 by infinity will be almost 0. So it is nothing but, we can write it here. So that gives you V is equal to minus Q by 4 pi epsilon into minus 1 by R. So that will give you V is equal to Q by 4 pi epsilon, where epsilon is the absolute permittivity, and it is nothing but, for free space we can write down V is equal to Q by 4 pi epsilon 0. This one, it is for free space. So that's all for now. We'll meet again in my next video. So thank you all for watching, and one declaration I want to make for the diploma students. So I will be starting very soon a separate, obviously, YouTube channel for specifically for diploma students and diploma in electrical engineering students. All the electrical subjects I will be teaching there, and the basics will be taught in that particular YouTube channel. So thank you all for watching, and please, if you like it, please like, share and subscribe to my channel. Thank you all.